everyone, my name is Maria and I will give you a brief introduction to our paper in which we present our path generation framework Connect. In our paper we show that information which stays implicit in text can be represented as single and multi-hop common sense knowledge paths which connect relevant concepts from two given sentences. We propose Connect, our framework that we developed for automatically establishing such paths. The first step is to extract relevant concepts from two given sentences and then to dynamically establish single and multi-hop knowledge paths between them by combining two complementary model types, a relation classifier and a target prediction system. We then evaluate the quality of the established path manually and automatically on two argumentative datasets and show that our framework can generate meaningful, high-quality knowledge paths between sentences that reveal implicit knowledge conveyed in texts. If you want to know more about our framework or are interested in some more example generations, we invite you to come to our gather spot.
Hello, I'm going to tell you about computing all quantifier scopes with CCG. A sentence like every farmer owns a donkey is an ambiguous sentence and has two different readings shown below. The main difference between them is the scope between existential and universal quantifier. Stinojevic 2011 replaces all existential quantifiers by Skolem functions, and we get two different readings by Skolem function getting two different arguments. Now, these formulas with Skolem functions are computed over standard syntactic derivations, and we get two different readings depending on where do we specify the arguments for the Skolem function, as shown by the dotted lines on left and right. And in this paper, we show how all of these potentially exponentially many derivations can be packed into one single derivation that captures all possible readings.
In this paper, we focus on the science question answering task, which requires explanatory knowledge, such as scientific facts, in the inference process. Our hypothesis is that the explanatory knowledge can be implicitly encoded in neural representation, then be transferred to downstream question answering tasks. We propose a unified neural representation-based model that frames two tasks: explanatory knowledge reasoning and question answering. We have following conclusions from experiments. First, the proposed approach can deliver comparable zero-shot question answering capabilities, even compared to supervised models. Second, the pre-training on exploratory knowledge acquisition improves question answering inference capabilities and the generalization of neural representation models.
Hi, I'm Gregor. It's a pleasure to be here. In our paper, we are exploiting insights from critical thinking literature for neural language modeling. Basically, we create a corpus of argumentative texts, train GPT-2 on this corpus, and assess the performance of our trained model. We start from lots of different valid argument schemes in creating this corpus, use a multi-step templating pipeline, and finally obtain promising results which suggest that critical thinking intermediary pre-training on texts which exemplify basic reasoning skills can improve performance on a broad variety of reasoning tasks. I hope to see you at the paper session.
Imagine to read these two sentences. The cat eats the mouse and the cat eats the airplane. You probably would need more time to read the word airplane if compared to the word mouse. And that's because reading behavior reflects language processing, which is influenced by the semantic coherence between the context and the target word, and the predictability of the target word given the context. In computational modeling, the former has been successfully modeled using the cosine similarity between the vector representing the context and the one representing the target word. while the second is modeled using the surprisal of the target word given the context. Anyway, a debate is still ongoing about how truly different are these two computational tools, and to what extent they represent overlapping information. In our study, we computed the correlations between three eye-tracking features and the cosine similarity, and between these three features and the surprisal. We also compared different word embedding models and language models. So, if you want to know who is the winner of this double competition, take a look at our paper.
Hello everyone, I'm Chen. I'm happy to present monotonicity marking from universal dependency trees, a joint research with my partner Qiyue Gao. Monotonicity reasoning is an essential part of logic and semantics, and it requires polarity marks provided by annotation tools. Universal dependency parsing is a tool widely used in NLP and provides accurate and informative parsing. However, no work has utilized the universal dependency for monotonicity annotation. We propose a system that annotates monotonicity information based on universal dependency trees. We first binarize UD trees into binary trees. Then we traverse through each node and mark polarities according to polarization rules associated with dependency relations. Compared to prior systems, we achieved a state-of-the-art performance on a small evaluation dataset. For more information, please see our GitHub page. Thank you so much.
Hi, I'm Katerina Kalouli and I would like to invite you to check out our paper on Is that really a question? Going beyond factoid questions in NLP. The motivation behind this work is that current QA and dialogue systems are not on par with human communication. They mainly focus on factoid questions and they miss out on other communication goals. For example, questions posed as sarcastic comments or rhetorical questions, or questions posed to express surprise or to make a decision, or deliberative questions. So the goal and contribution behind this work is to first of all propose the task of question type identification. Given a question, we want to determine whether it is an information-seeking question or a non-information-seeking question. To do that, we provide Rocket, the first openly available QTI corpus to be used as an initial benchmark. We are also able to establish suitable baselines for the task. We use simple and more complex features to train linear and neural classifiers. We are also able to generate linguistics insight and set the scene for future research in this area. If you are interested in more details, check out our poster and stop by in Gather. Thank you.
Hey there, thanks for checking out our video. Please come check out our paper about frames and rules in frame semantic parsing. Frame semantic parsing is the task of automatically annotating a text with framenet structures, which provide rich conceptual information about events and situations and can be used for various downstream tasks. Traditionally, frame semantic parsing is done using a three-step pipeline. Identify predicates first, then find the correct semantic frame, then label the semantic rules of that frame. Quite a bit is known about each component individually, but not much at all about how they interact. Our paper addresses this by looking at different combinations and orders of components and how this influences end-to-end scores. That's it for now. I hope to see you at our virtual poster stand at IWCS 2021.
Hi, I'm Bill Noble, and this is work together with Vladislav Murayev. We wanted to see whether BERT learns semantic representations that are specifically useful for dialogue. So we tested BERT as an utterance encoder for an RNN-based dialogue act recognition model. There are many dialogue-specific phenomenon that standard pre-trained BERT doesn't have exposure to, both at the discourse level and internal to utterances. Things like disfluencies, non-verbal vocalizations, and non-sentential utterances. Many of these phenomenon can have a role in determining the dialogue act. So we tested a standard pre-trained BERT model against a randomly initialized BERT model, fine-tuning the weights on the dialogue act recognition task in both cases. We also tried with freezing the pre-trained model and only training the RNN layer on the dialogue act task. We found that while the pre-trained model did a little better, the frozen model did horribly, suggesting that while there's some useful information in the pre-trained BERT representations, fine-tuning is absolutely essential to use BERT on dialogue. We also tried adapting BERT to dialogue-like data before exposing it to the dialogue act recognition task, but you'll have to read the paper to see those results.
In this paper, we explore alternative approaches and training datasets for both components of the two-step NLU pipeline shown here, developed to support human-robot dialogue. In the first step, the pipeline leverages AMR parsing to capture the propositional content of the utterance. In the second step, this is converted into dialogue AMR, which adds information on speech act, tense and aspect, and also updates the main action relation of the standard AMR to a consistent robot concept relation corresponding to an executable robot behavior. So with each step, this pipeline smooths over some of the complexities of language that may be unimportant for the robot, which must determine how an instruction corresponds to one of its behaviors before responding. Our focus is on evaluating this pipeline on two collaborative domains, human-robot dialogue for search and navigation, and human-human dialogue for collaborative building in the Minecraft gaming environment. We achieve promising performance in both domains with very little new training data, demonstrating the scalability of this approach.
Thank you for taking interest in our talk about variation in framing. In order to understand streams of news in terms of the ways in which events can be framed, we need to model how these streams develop over time in relation to the common ground with the audience. We assume that the temporal distance between the event and the text affects this common ground and leads to the need to foreground the main event or implicate the main event in order to foreground related events. In this paper, we present the HDD corpus, which contains texts about different event types processed with frame annotations and a large spread of temporal distance. Our contrastive analysis of the frame annotations resulted in a ranking of frames typically used in reference to the event type, but a different distribution of the typical frames as a function of the temporal distance of the corpus. We also trained a classifier with the frame annotations in order to let it predict the temporal distance class given a document. We compared this to a baseline of predicates. Join the session to get a deeper look into the results and analysis.
Hi, we are Nele and Jana, and today we present our work on attributes in adjective noun phrases. Attributes represent knowledge about real-world entities or events. Attribute meaning is often conveyed in adjective noun phrases. For instance, in the phrase windy day, the adjective windy describes the climate of the day, whereas in the phrase heavy rain, the adjective heavy refers to the intensity of the rain.
In our work, we looked at whether we could automatically predict these attributes through machine learning using adjective and noun as input. To do this, we created a dataset of German adjective noun phrases. In our experiments, we evaluated different embedding types and found out which attributes are especially difficult to model. How good do the models generalize to unseen data? How do semantic transparency and ambiguity affect the performance? If you want to know the answers, come to our poster.